Hi, everybody. I decided to do this one again. I went back and looked at my U.2 video, and it was unfortunate. I went into way too much detail, and you guys just want to know how to do it. So I'm going to do a faster one. Here it is. This is U.2, Solving Systems by Graphing. And my first suggestion is that you scroll down and get to where your equations are listed, and they're listed by color. Now, what I'm going to do is I'm going to be pushing on the one that I want to graph. So I want to graph the purple one first, and I'm going to go through 0, -1, and then I'm going to count the slope. I'm going to go down 2 and over 1 from there. Now, the big thing is you want to toggle your green equation now. So I'm going to choose the green equation. If I forget to do this, it'll jump around and change my graph. So I'm going to choose the green equation now. And of course, I'm graphing 0, 2, and I have a slope of -1. And there's my two lines. And it looks like they're intersecting there at 3, 5, right up there at 3, 5. And hopefully you can see where my intersection I just pointed at. And I type in the solution 3, 5. And before I hit submit, what I like to do is substitute the 3 in for x in my head for the purple equation. And sure enough, that gives me -6 minus 1, which is -7. So that's not it. So I made a mistake. Do you see why I did that? This is supposed to be -3, isn't it? See how it's easy to make an error there? But if you substitute in your values, then you can check your answer, okay? So lots of things going on there, but just give it a try. You'll be surprised at how important, how much it helps and how much it'll work. So I'm gonna go a lot faster now. Now this one, notice that my slopes are -1 and +1. I'm just gonna graph them. I go through, and once again, I'm gonna go down to where my colors are. So I'm going to go to -3, and I'm going to count my slope down 1 over 1. I'm going to go to +3, and I'm going to count my slope, and then I'm going to go to the intersection. Be careful. That intersection point there is at -3, 0, not 0, -3. -3, 0. And again, I check my answer. The opposite of -3 is +3 minus 3 is 0, and -3 plus 3 is 0. So it's correct. I'm going to go a little faster, maybe. Let's see. We're going to go through. Let's get my graphs. Here we go. So my orange graph is going to go through 0, 3. It has a slope of -1. My blue graph is going to go through 0, 5, and it's going to have a slope of -2. And notice that I'm going through 2, 1 there. And this one is a lot easier to check. -2 plus 1, -2 plus 3 is 1, and -4 plus 5 is 1. So yep, there it is. You can see my Gary Larson tribute up here. Yeah, that's the, hey guys, look, I'm a cowboy. All right, so we've got y equals 3x. So that goes through 0, 0 and has a slope of 3. My blue one or purple one goes to 0, -4, has a slope of -1. And it looks like my intersection is at 1, -3, 1. Oh, how about -1? Keep doing that. -3. -1, -3, and sure enough, it's the correct answer. Again, easy to make an error on reading your numbers. Now, don't let this one freak you out. I already know the answer. It's 1, 5, guys. X is 1, Y is 5. Duh. 1, 5, but you're supposed to graph them. Now, something to keep in mind. This purple equation is not a function. It is the only line that is not a function. It's where x is equal to 1, has an undefined slope straight up and down. And of course, y equals 5 is a function. In fact, it's called a constant function. The intersection, of course, is at 1, 5. All right, hopefully we'll get some more interesting ones coming here. Oh, now we're getting a little more interesting. Now I'm going to go ahead and each time for these, at least to start, I think I'm going to go ahead and graph this 2x minus y equals 4. Most people are going to be tempted to solve for y, and you certainly can do that. You subtract the 2x from both sides and change the sign. So if I subtract the 2x from both sides, and change it to negative 2x plus 4, and then change all the signs by dividing by -1, or IXL will tell you to multiply everything by -1. You get 2x minus 4, and then you could graph it that way. That is not what I like to do. Whenever I have a standard form equation, I use the intercepts, and here's how it works for me. 2x minus y equals 4. So in my head, I imagine that x is 0. And then I know that this is gone and negative y equals 4, so it's going to be at -4. Then, forget the 2x is still there, I let y equal 0. And in that case, 2x equals 4 and x is 2. And of course, those two solutions can be graphed. Now be careful, that's an x-intercept. This is a y-intercept. Oh, let me make sure I'm in the right equation here. Probably am. Yeah, it's the green one. So 2, 0 is on the x-axis. It is an x-intercept. 0, -4 is on the y-axis. Now I could have just as easily gone 2x minus 4, but for me, I think it's easier to do the intercepts. It's a little faster. Anyway, the purple equation goes to 0, 5, has a slope of -1, and there it is. It looks like my solution is at 3, 2. Let's see if that's true. And 3 times 2 is 6, minus 2 is 4, yeah. And -3 plus 5 is 2. Yay, got it. All right. Now I'm going to go a lot faster. All right, so x minus y equals -4. So my x-intercept is when y is 0, in which case x is -4. Let me go down here. So when y is 0, x is -4. When x is 0, y is +4. It's that easy. I'm doing the work in my head, but it's not that, pretty easy. Don't forget to choose your other equation. We're going to go through 0, 0, because 0 times 5 is 0. Has a slope of 5. That's up 5 and over 1. And we're at 1, 5. Yay. And sure enough, I've already put both answers into both equations, and I can see that it's correct. 1 times 5 is 5, and 1 minus 5 is -4. This takes so long, but it's so fun. Okay, remember, x equals -6 is a vertical line. Let's graph our orange equation first. We've got 0, -1. I'm gonna, it's all right. And then I have a slope of -1. And then for my blue equation, I'm looking at x equals -6, which is right there. And there's my solution at -6, 5, it looks like. Now, I am going to check it because it is really easy to make an error there. Erase my dots. All right. So notice in the orange equation that we're taking the opposite of x, which is +6 minus 1, gives you 5. Of course, the second equation has to be true because x has to be -6. And there we go. All right. Oh, almost look parallel, don't they? Remember, these are not perpendicular. In order to be perpendicular, they have to be negatives of one another or opposite slopes, but they also have to be reciprocals to be perpendicular. If I want two perpendicular lines, remember that if one of the slopes is 1/3, for example, the perpendicular slope, and this is how I write it, that's the symbol for perpendicular, is -3/1, just so it doesn't freak you out when you don't get perpendicular lines here. All right, orange equation, I am going to go through -4, 0, -4, and I have a slope 1/3. There we go, done. I'm going to go through -2, 0, -2. I have a slope of -1/3. And look at there. We are at 3, -3, it looks like. And sure enough, 3, -3 works in the first equation as well as the second. Yes, it does. Okay. I really like x minus y equals 2. And I'm going to show you something, how I tend to graph this one totally different than all other kinds of graphs. And you're going to like this because I think when you see it, how I do it, it'll make sense to you. And a second grader could do it this way. Check this out. So what I'm going to do is I'm going to think of two numbers that when I subtract them, I get 2. So you think of two numbers that when you subtract them, you get 2. How about 3 minus 1? Isn't that 2? How about if I go to 3, 1? 5 minus 3, that's 2. How about if I go to 5, 3? Wait a minute, what did I do? 3, 1. Oh, 3, 1, I didn't graph 3, 1. Oops, sorry. It helps if I actually graph 3, 1. There we go. Sorry about that. Dang, nothing like messing it up. So for the purple one, 3, 1, if I subtract them, x minus y, I get 2. And 5, 3, if I subtract them, I get 2. And notice that it's on the line. And of course, you always have the option of going with the 0, -2, which is right there, and the 2, 0, which is right there. There it is. Anyway, there it is. Y equals -6 is that horizontal line that goes right here. Oh, there's it. These guys. And let's check my solution real quick down here. God, I can't believe I messed that up. Okay, let's check my solution. It is at -4, -6, it looks like. Kind of an odd solution there. If you subtract x minus y, you end up with -4 plus 6, which is 2. And of course, the y is -6, so it's correct. Nothing like graphing 1, 3 instead of 3, 1. All right, 2x, and I'm going to use the, I'm going to go ahead and do the intercepts on the side. 2x minus 3y equals 6. Now, what I usually do is I do this in my head, but I want to show you what I'm doing. What I'm doing is I'm covering up the 2x in my head and solving for y. And then I'm covering up the -3y in my head by putting 0 for y, and then I'm solving for x. 2x equals 6, so it's 3. These 2 points make that purple equation true. So it's at 0, -2, and 3, 0. There we go. You can solve for y, it doesn't matter. And for this one, of course, we go through 0, -4, and we have a slope of 1. And there it is. Looks like my solution is at 6, 2. It should be easy to check that. 6 is 12, minus 6 is 6, yep. And 6 minus 4 is 2, yep, it works. I'm just substituting in my head. Oh God, I'm hunching like that vulture with the cowboy hat on. All right, 2, -1, done. Seriously. 2, don't let this one freak you out, -1. Remember that my blue line is a vertical line and my orange line is a horizontal line. And they do intersect at 2, -1, don't they? Okay, this is a substitution. Some people are going to say, oh, wait a minute. Why would I want to go to all the trouble of graphing this when I can just substitute the y into the first equation and solve it, which gives you -1. So the answer is going to be -1, -3. You know, that's fine, but you're supposed to graph them. So let's graph 1. Oops, come on. Can't see it. Oh, there it is, 1. Has a slope of 4. That's up 4 over 1, and we're done. And then y equals -3, so we're looking at this one. And our solution is at 1, -3. So, excuse me, it looks like we're at -1, -3. I actually think I got the negatives right this time. -1, -3. Now, of course, the y is equal to -3, so we know that's right. And we want to check the other one. So if I put a -1 in for the x, I get -4 plus 1 is -3. So yeah, that's right. All right, we're getting there. Let's see, what's the next one? Okay, x equals 6, and 2/3 of 6 is 4, minus 1 is 3. So we know it's going to be 6, 3, but we actually want to graph them. So here they are, -1, and we go up to 2/3, and then we do x equals 6, which is right there, and we are at 6, 3, sure enough. And since I had already worked it out, I know it's correct. And we'll just keep on going here. Let's see. Now this time, sometimes I solve for y, sometimes I don't. I think it's fine. Just put in the, I'm just going to do the intercepts. If x is 0, y is 2. And if y is 0, x is -2. And then I'm going to graph the other one, which goes through 6 and has a slope of -1/3. And there's my point at 3, 5, it looks like. 5. And sure enough, 3 minus 5 is -2. And 3 times -1/3 does give me -1 plus 6, which is 5. Okay. Probably have to do at least 5 of these, hopefully fewer than that, but you never know. All right, so let's scroll down my equations. I'm at -2, and I have a slope of -1/2. I'm at -4, I have a slope of -3/2, and it looks like I'm at -2, -1. And let's do the next one. I'm at 0. Oh, you know what? Scroll down. 0, 4, have a slope of 1/2. I'm at 1, and I have a slope of -1/4. And it looks like my solution is at -4, too. Okay. We are at -4, and we have a slope of -1/2. We're at +4, and we have a slope of 3/2. And it looks like our solution is at -4, -2. It works for the first green one, and it works for the second one. Maybe one more. Oh, I like this one. Okay. So we've got both of them in standard form. So I'm going to use intercepts in both cases. So when I do the blue one, notice that when y is 0, when y is 0, x is 3. It's right there. When x is 0, y is 1. It's right there. Now, when y is 0, x is 3. And when x is 0, y is -1. And there's our solution. At x equal to 3, which 3, 0 makes them both true, doesn't it? And you can see that that's true. 3, 0. A really common mistake is to call this 0, 3. So clearly a good check would be in order there. And it looks like we have a final one here. And here it is. Oh, I really like that. I like this blue one because it's so easy to do your intercepts. You just have to be really careful. Remember that the intercepts we're looking for, when y is 0, x is -5. And when x is 0, y is -4. Notice both of those intercepts have to be negatives, of course. And then on our orange equation, we're going through 0, -2, and we have a slope of -2/5. There it is. And it looks like it's at -4, 0. Oh, -5, 0. I've got to read it right. -5, 0. And for the first equation, for the blue one, of course it's true. And for the second equation, it is also true because that -5 gives me a +2 minus 2. There it is. I hope it helped. Hopefully you like this one much better than my other crazy one where I went crazy with the explanation. So I will see you back again. Bye, everybody.